Hi, everybody. Is this on? Yes. Okay. Hi. Um, First off, before I start anything, this talk is not about rack. If you read the description on the website, you might think it's about rack, but that was just some bad copy pasta. So, as said, I'm Konstatin. I'm an open source developer. Konstatin Haase on Twitter and on, I don't know if you know that, but there's that sticker company called GitHub. They also do code hosting. Anyways, I'm RKH on GitHub if you want to check out the horrible code I'm writing. I came here from Berlin. My flight was delayed because of snow. Can you imagine being too late to Cape Town because of snow? And I work on a bunch of open source projects, including Travis. I'm maintaining Sinatra. I work on Rack, Rubinius, and Tilt. And to continue advertising myself, I wrote a book together with Alan Harris about Sinatra. So if you want to learn more about Sinatra, check out this book. I promise you, unless you've read the book already, you will definitely learn something, no matter how well you might know Sinatra already. And there's a 50% discount code. Yeah. It's like 10 Rand or something. Okay, enough already. We want to talk about Ruby. So we all know Ruby. We all love Ruby. Ruby is really popular if you look at this index of how popular languages are. But I don't think this index is worth much, because otherwise the technology we should all be moving to is Object Pascal. So to know where Ruby is going, we should be looking at where Ruby is actually coming from. If you look into the history of Ruby or programming languages in general, there's this one really well-written blog post about the history of programming languages. And as it says, it's brief, incomplete, and mostly wrong. And it has a paragraph about Ruby. 1995, Yukihiro Mad Mads Matsumoto creates Ruby to avert some vaguely unspecific apocalypse that will leave Australia a desert run by Mohawk warriors and Tina Turner. The language is later renamed Ruby on Rails by its real inventor, David Heinemeier Hansen. This is Yukihiro Matsumoto. He's a really nice guy from Japan, and he created Ruby. That's how you spell his name in Japanese, I think. I copied that from his Facebook page. Maybe it's something else I copied. Yes. So I was wondering, why do people use Ruby? And if there's one thing that Chad Fowler ever taught me is, if you need content for your slides, just post something on Twitter and copy that. So I asked on Twitter, why do you use Ruby? And so if you ask something like that on Twitter, the first thing that happens is you get trolled. The second thing that happens is you get even more trolled. And yeah, it continued. After about three trolling comments, the first real replies came in, and there are a bunch of different categories. One reasoning was that people are, sorry, go back. Yeah, no. There we go. Yeah, I'm not that good with technology. So one of the reasons was that people are already using Ruby to build things that are apparently really cool, like Rails, Sinatra, Puppet, whatever. So Ruby has to be a good thing to use, right? Yeah, I guess it's somewhat valid. A lot of people apparently use it because it's easy, because it's pretty, it's a nice language. Sounds better to me, at least. Like when I'm selling Ruby, I don't want to sell it because it's, you should use Ruby because everyone else uses it. And then there's a category, I guess I saw a lot of hands that have been using Ruby for more than 5 years. So one of the reasons to use Ruby is because you already know it really well, which I think is a really, really good reason to use a programming language. It's also a really good reason to start looking into other things, maybe. I got a really special response from Peter Cooper. He wrote that, and I think he himself figured out that that doesn't really explain anything, so he basically wrote me a blog post on a gist. Yeah, if you can't see the URL, hit me up later. It's basically an article explaining why he doesn't like Python. And really interestingly, I got basically I got basically the same reply both from Steve Klapnick and DHH. Like even the image they used is really similar. And the only real valid reply, I think, was from Aaron, who said, I like Ruby because of those features. Oh, well, the other valid reply was from Terence. This stands for what would Gorbypuff do? And by that, he obviously means Gorby Thunderhorse, the most famous cat on the internet. I personally like Ruby because it's like Smalltalk, except it's not. It has a lot of the advantages of Smalltalk, not all of them, without having a lot of the downsides. Like in Smalltalk, you're trapped in this whole image thing that was really cool in the 80s, but somehow missed everything going on in tech ever since. It's a general purpose, fully object-oriented, dynamically typed, strongly typed, mature language that has a low entry barrier. And one of the biggest features, in my opinion, and you probably agree with me because you're sitting in this room, is the amazing community. Wherever you go, Ruby developers, even if the community is smaller, they innovate, they are open. I mean, I work on open source full time, and I don't know how that happened. So, and I kind of attribute that to the Ruby community. But let's get back to where Ruby is coming from. You saw in the article, like the heading said, that it's mostly incorrect. And actually, Ruby was not created in 1995. Apart from that, it's mostly correct. But actually, 1995 was the first public release, but it was created in 93. Actually, in February 93, February 24th. So it will be 20 soon. So Ruby is already 20 years old. Sounds maybe like meh, but if you think about it, just for reference, this is me 20 years ago. Already playing with Rails, but that's what a desktop computer looked like 20 years ago. And this is the internet 20 years ago. And 20 years ago, there was still, to put this into perspective, there was still 1 year to go to the first universal election in South Africa. But could be going on about what the world looked like 20 years ago, but we actually want to talk about Ruby. So when we say Ruby, there are two things we might be referring to. Ruby, the language, which is what we write, and Ruby, the implementation, which is the program we use to run whatever we just wrote. And so when we say, yeah, Ruby looks really beautiful, what we mean is the language. When we say Java wasn't slow enough, what we mean is the implementation. And sometimes it's really hard to separate the two because they obviously influence each other. So let's talk about the language. The language has a algol, other Eiffel-like syntax. That's what Mats himself said. Today it looks more a bit like Perl, but and there's an interesting thing about that. So one of the first things that Mats did when he implemented Ruby was writing in Emacs mode, because it's actually, Ruby is heavily inspired, but I get to that in a second, by Emacs. And he just needed to have an Emacs mode. And he needed syntax highlighting and auto indentation. And that heavily influenced what the Ruby syntax looks like. Because if he wouldn't have been able to write an auto indenter that deals with do and end, we would not have do and end in Ruby today. Luckily, he managed after a week to implement that. Otherwise, Ruby would be looking different. And yeah, so as I already mentioned, internally, it's a Smalltalk-like object model. Like, it's mostly message sending and late binding, which allows us to change what a Ruby program looks like at runtime, et cetera, et cetera. Most of the things we like. I guess I'm just preaching to the choir here. So let's go on. And the main Ruby implementation internally is modeled after the Emacs Lisp implementation, because that was the code that Mats played with before starting Ruby. So the C API is really similar. It's using tag pointers, where you basically, any entry that's a pointer can actually be either a real pointer, or depending on the first byte, it can just be an integer without having to point somewhere where the integer is stored. The garbage collector, the mark and sweep garbage collector is modeled after the Emacs Lisp garbage collector, et cetera, et cetera. But so, what's new in Ruby, the language? I'm going to keep that brief. Some of you probably saw that in all the discussions. One new thing is refinements, but it's kind of not, so it's a bit unclear if it's like big feature or if you shouldn't use it. It has been added to Ruby 2.0, to Ruby trunk. Then there was discussion about removing it. It's marked experimental. What it basically does, it allows you to write a monkey patch, but only for lexical scope. So only from within this module does string have the following method. That's what you can do with it. And there's a lot of controversy, and going into that would be a talk on its own. The discussion on Ruby core is actually quite extensive, but quite interesting to follow. So you should check that out. And two other new features that I actually like that are coming in the language version 2.0 is module prepend, which is just like include, except the other way around. If you include a module, it's like inheriting from that module in the class, whereas if you prepend a module, it's like if you had an instance of that module that inherited from your class. That's actually important for if, the only use case where that's important is when you override methods, where today you would use alias method chain. Imagine you want the normal hash access, or just normal hashes, to always, before actually doing the hash access, convert the key into a string. And what you would do today is alias the hash access to something else, then override it, or usually in Rails world you would even like give it a different name, then alias that to the normal access, and in there call that other method, which if you do that a lot can give you quite some headache. And with prepend you can just basically add that method in front of the normal hash access method. I'm not saying you should do this, just wanted to find a simple example which is not nonsense. And the other new thing is keyword arguments. It's like the option hash thing, but now a real part of the language. So this down here will actually not be passed on as a hash. Instead, foo takes two arguments, a and b. And usually, if you wouldn't have keyword arguments, if you just want to change the value of b, you would also have to pass in a, and would have to know what the default value of a is. But with this keyword syntax, you can just set b like this. And one thing I like about this too is that you only have to change the method signature if you're already using option hashes and not the place where it's called. There's syntax for give me the rest of the hash, and if you don't have that, it will if you would say C, it would raise an exception, etc. Okay, but let's talk about the implementation. There's actually more than one implementation. It's one language with many implementations. Any guesses on how many, or do you know any alternative Ruby implementations? Come on, yell at me. Rubinius, yes. JRuby. What? Topaz. It was released yesterday, but damn you. Yes, so any guesses as how many there are approximately? Lots. Yeah, I counted, so if you count everything in that itself tries to call, like if you count everything in where someone just has the idea and starts writing some code, I got to about 60. If any implementation is missing, please come and talk to me. The pass is there. The most well-known, or the one we usually call Ruby, is the reference implementation, which is 1.9 and 2.0. 1.8 is no longer the reference implementation because 1.8 has been discontinued. So that's like the thing we always have to compare to. And the rest of the implementations I like to categorize in full replacements, which is basically JRuby and Rubinius. It used to be Ruby Enterprise Edition 2, but that also has been discontinued. And then there are niche Rubies, which are basically already usable, but you would not just use them for your normal Rails application. You would always have a special reason to use them. For instance, you would use MacRuby to write a desktop application for OS X, for OS X. But you wouldn't use it to run your Rails production application. And everything else is pretty much either dead or not there yet. So they're interesting projects to look at, but nothing you would really use. Yeah, and so, but still, that's quite some project to choose from. And so what are the criteria? What are we looking for in a Ruby implementation? Are we looking for stability? One thing, like all the major implementations are using Travis CI for testing, which is really cool, I think. But that's not the only thing that gives you stability. It's basically just code quality and trying things out, etc. But it's really important in a Ruby implementation. One other thing that we want is performance. Should run our code really fast, right? Sometimes it's one of the main criteria overall. But I think often it's actually over, it's not, like performance itself is not as important. Like it's really important on the level it is right now, but on your app level, maybe if performance is the most important thing, maybe you should not be using Ruby. Efficiency, like it should not have memory leaks, it should be low in memory, it should support copy on write, etc., etc. And it should also have a good tooling. I want to be able to debug my application. It should be called Visual VM, not Virtual VM. That's a thing where you can debug a JVM. It's really cool with JRuby. If you use JRuby, check that out. If you use Rubinius, you should check out remote agents, which gives you really cool debugging of running processes. And compatibility. This is actually something, even though it's a big topic, one of the biggest when talking about implementations, this is actually something Ruby is really good at. Because compatibility in Ruby land is my Ruby implementation should be able to run Rails, and if not, I'll adjust my Ruby implementation. Whereas compatibility, for instance, in Smalltalk there's also a big web framework that's called Seaside. And the way compatibility is handled in Smalltalk is Seaside doesn't run on my Smalltalk implementation, so let's adjust Seaside. And then a whole bunch of special features, which is especially important for the niche implementations. So to ensure compatibility, or to ensure that the language is heading into a good direction, a lot of people from the alternative implementations and also from Ruby Core, which is the team behind MRI, started an implementers meeting. It's actually the second time this has been tried. They first did it in 2008, and now they already had 2 meetings, I think. One in December, one in January. And in the December meeting, Brian Ford, Aaron Patterson, and a few others proposed a new process where basically you have a proposal process, like in the Python world, where you can propose a new feature, then someone from the Ruby committee has to present it, it has to have specs and documentation, and people need to agree that they want this feature. And the discussion went on, and everyone was like, yeah, this sounds good, and I want to add that, and well, I think we should not always require a specification, like basically details in the process. And then Mats said, yeah, I understand where you're coming from, but no. So that's, when I read that, it was actually kind of a downer to me, but on the other hand, they agreed to do those implementers meeting on a regular basis and definitely improve communication and maybe work out some process that everyone can agree with. So the situation is improving. It's getting better, and we'll see what happens. Let's get back to the implementations. What's going on there? So by now, all the implementations are using virtual machines. Quick run through virtual machines. Like, what does that mean? I have my text file here, and somehow something gets executed on the CPU. So what happens in basically all the Ruby implementations is you start with the source code, which is Ruby, the language, and there's a parser that parses it, turns it into a parse tree, and then you could already have a program that walks that parse tree in memory and executes corresponding CPU instructions, which you would call an interpreter, which is what Ruby 1.8 and every version prior to that did. Or you could also turn that into bytecode, which is basically like machine code, just for virtual machines, not for something in hardware, but for software, which basically is just a giant while loop that will always take another byte, and depending on what that byte is, execute something, or an instruction. And with that bytecode, so if you do that, that would interpreting the bytecode. So basically, Ruby 1.9 is still interpreted. It's just not the parse tree that's interpreted, it's the bytecode that's interpreted. Ruby 1.9 does not generate any machine code. Neither does Ruby 2.0. And yeah, that will invoke CPU instructions. Or what you could also do is you could just in time compile it to real machine code. But that might be expensive, so you only want to do that for code that's important, that's invoked a lot. And also, that's only really efficient if you do jumps directly into other methods. So you want to do figure out the dispatch at that time and be able to, at runtime, throw away the machine code if something changes, etc., which is what JRuby and Rubinius and a lot of other Rubies do. And yeah, so under the hood, everyone generates bytecode. To give you a feeling for that, the bytecode for this line looks like that on MRI, the standard implementation. So a take value and send to S with no arguments to it. On Rubinius, it looks like that. Push the first local, which is value, onto the stack, and send to S with no arguments to it. It's actually pretty readable. That's not the bytecode, that's the textual representation. It's like the assembler for those machines. Actually, this would be just a 1-byte instruction and not push local in some text file. And on JRuby, it could look something like that. I'm not going through that right now. But that's actually, it's not bad that it looks like that. It's just due to the JVM being written for Java and not for Ruby. And the JVM is actually a really good VM. And it's not like you always read the bytecode of a program, right? So let's take a look at MRI. What's actually going on there? Since 1.9, as I said, it's a virtual machine. One of the features, one of the biggest features and biggest issues that MRI has, in my opinion, is the internal C API, is the external C API. Means you cannot change the internals of the, short of a complete rewrite, it's really hard to change the internals of the C API without breaking C extensions, which is also why it's probably not getting a JIT anytime soon. If you want to know more about that, come talk to me later. It has, as you might be aware, a global lock. I mean, since 1.9, Ruby threads are actually native threads, but they cannot really run in parallel if you have multiple CPUs because of the global lock. Basically because types are not thread safe internally in Ruby. That is actually in most cases not as bad as it seems, because most of the time threads will be waiting on I/O anyways, which operating systems are really good at scheduling. But if you run CPU-intense tasks, it's really hard to parallelize them within one Ruby process. And it has a conservative garbage collector. It's also a mark and sweep garbage collector, but that's not related to it being conservative. So what it basically does for collecting garbage, it's not like a garbage collector basically starts with some objects and knows those objects are still alive. And then a mark and sweep garbage collector, at least, it checks out which objects those objects point to, and they are also alive, so they are all getting marked. And then once that mark phase is over, it looks at all the objects, and whichever object has not been marked just gets removed, which is the sweep part. And the main difference between a precise mark and sweep garbage collector and a conservative mark and sweep garbage collector is where you get the initial set of objects from that are alive. And So you could just keep track of every object that's being created from the, like, in global variables or in the current execution stack frame, local variables, etc. You could just keep track of that. But Ruby doesn't do that. What it does instead is it looks at the C stack, which is where the machine actually keeps the pointers. Like, all your objects live in the heap, which is basically sorted, allocated memory where you can write stuff. But all your execution, like everything that in C would be a direct reference and not a pointer, is on the stack. So Ruby scans the stack for, like, there's just bytes on there, there's everything on there. But it scans it for what looks like a pointer into the heap. And then that object gets marked. And that's also how you would implement a garbage collector for C. And the big issue is that you can, for instance, keep a reference in a register on your CPU. And then when the garbage collector kicks in at that point, that object doesn't get marked, gets removed. And you push that reference back onto the stack, try to access the object, and boom, you have a segmentation fault. Which is also why you're not supposed to compile Ruby with -03, which tells GCC to enable as many optimizations as possible, because that will write a lot of things to registers. Or it's one of the reasons why you shouldn't that. But okay, talk to me about basically anything that I talk about and you want to know more about, talk to me later. The 2.0 release will be binary interface compatible. It means you don't have to 193, which even 192 was not ABI compatible, I think, to 193, which means you don't have to recompile your C extensions. And there's support for tail recursion coming, which basically, if you have a method that either just returns a value or invokes itself again, which often happens, that would result in a giant stack and maybe in a stack level too deep. And tail recursion allows you to translate, internally translates that into a while loop, which makes it really, really efficient. And as I already said, it does not do machine code generation. JRuby. Where JRuby is going and where JRuby is at yet, which is the big buzzword in the Java world, invoke dynamic. If you want to know how invoke dynamic works, talk to me later. Basically, what it does is it explains the Ruby dispatch to the JVM, which means that the JVM can do stuff like inlining and then compile that to machine code efficiently. And JRuby, all the current releases are doing that for method dispatches. And I think they're also already doing that for if you reference a constant. But there's actually a lot of things that are similar to dispatches, like variable access, etc. And JRuby is constantly improving on that end. JRuby also supports a C API, but they are going to drop support for that because that's such a hassle. And so you can run a C extension written for MRI on JRuby, but it's going to be slow. It's probably going to leak memory. So they have deprecated that, and that will be removed. So if you interact with some shared library or something, you should use FFI instead for a function interface. And one of the cool things about JRuby is it has no global lock, so CPU-intense parallelized tasks run really, really well on it. And it has an ever-improving Java integration. For instance, this is some live code from Travis we use for dealing with encodings. We wrote our own library because the encoding situation is quite messy. And we just reference a Java class from here and just send a method. This is actually a Java method, but we don't have to care about that, and the Java part doesn't have to know about that. JRuby just takes care of all the plumbing. And it has a precise GC, which we just talked about. The next really popular one is Rubinius. What I really like about Rubinius, it's a hacker stream. If you want to play with language implementation. Rubinius is a great place to do that. You can do most of it in Ruby. I know if you know flip-flops, it's the weirdest feature of Ruby ever. And Rubinius didn't support that, and I implemented it in just Ruby without ever touching the VM. And the 2.0 release is coming up soon, which is the production-ready release. It will not have a global lock. It will allow you zero overhead remote debugging, which means you can actually, if something's going wrong in your running production process, you can over network attach a debugger to it and see what's going on without slowing down that process, which is something really cool. And yeah, the upcoming release will be 1.9 and partly 2.0 compatible. Will have Windows support, and it also has a precise GC. One other implementation that I really like is maglev. It runs on a Gemstone Smalltalk VM, which is it's a VM that's really good at running Smalltalk. And as we've established, Smalltalk is really similar to Ruby. So it's also really good at running Ruby. They needed next to no adjustments for running Ruby. I think only the exception handling is really different between Ruby and Smalltalk. And one of the cool features is it has a built-in object database. It means you can just say, store this object, and it will store all this object and all the object it points to. And it's not going to be serialized in any form it's not going to be mapped to a database entry. It's just being stored. And the cool thing is you can actually take a closure, a block with variable bindings, store that in the database, load it on a different maglev process, because one of those databases can be accessed by many processes at the same time, and just call that there. And instant background processes without data marshalling and whatever, which is a really cool thing. And since that's a Smalltalk implementation, and also a really old one, it has amazing tooling. I'm not sure who has ever done Smalltalk, but if you've used the Smalltalk debugger, every other debugger will basically suck. And debugging is one thing that Ruby is really not that good at, so it sucks even double. Basically, you can do stuff like go step back in the debugger, not just forward, and you can just click somewhere and say execute from here. And all the other tooling, you can just, this is actually maglev loaded in a Squeak VM that's talking to the Gemstone database. And what you can do is just say, what does array collect look like, and you get the source code. The big downside is the VM is not open source. You get a free VM with maglev, but actually they charge you for it. Maglev itself is open source though. Speaking of non-open source projects, RubyMotion is a pretty cool niche project that has been pretty hyped last year. It's basically MacRuby adjusted to run on iOS, which means you can write your iPhone apps in Ruby. As it's based on MacRuby, which is based on MRI, it shares some code with MRI. But as I said, it's not open source. It also costs a bit, but I guess that's if you don't mind anyways, if you're in iOS development. Then there's mRuby, which is embeddable Ruby. The use case is similar to where you would use Lua. It's developed by Mats, so it's based on 1.9. And one of the features is that it has ahead of time compilation, so you can compile it before running it. And you can use the LLVM JavaScript backend called emscripten to run it in your browser, which is also quite fun. Yeah, so it's called WebRuby. You should check that out. And one more thing. Who in here hasn't heard anything new yet? Okay, then I'm done. Thank you. Okay, some people in here already started spoiling that, but let's talk about Python. You should all use Python. Even Mats really likes Python. No, there's one really, really cool Python project. I'm not sure if you heard it, talking about language implementation. It's called PyPy, which is an alternative Python implementation that gives you speed, memory usage, compatibility, sandboxing, stackless mode. Sounds cool to me. I haven't talked about stackless, but it's cool, believe me. Remember that slide where we talked about how all the implementations work? Well, PyPy is different. PyPy doesn't do this in the classic way. It does that, but you don't write the code for it. What you basically do is you implement an interpreter, and the PyPy toolchain generates a VM for that, which is kind of cool. It's basically like the Rails effect for language implementations. If you remember that first Rails video and DHH going on, look at all the stuff I'm not doing. But it's also interesting from other perspectives, except for not having to write that. Because the technique, one of the main techniques it uses to achieve that is something called partial evaluation, which is something really cool. I actually did a workshop with one of the PyPy guys where he explained partial evaluation, and we played with partial evaluation in Prolog, which is also really cool. And I also really love Prolog, but that's a whole different story. It's kind of like Lisp macros, but without macros. So it's just like everything has all the cool features of macros, except you don't have to write macros. Sucky explanation. Maybe this one is better. I static, I dynamic O. No. Right? So what it basically does, it takes your program and generates a different program for you, which does less when it's run, but does the same thing because it's partially evaluated. Let's just check out what that means. Say you are PyPy, and for some reason you speak Ruby, and you want to partially evaluate this program. So well, you don't know what gets is, right? So that's a placeholder. You don't know what's coming from the outside, but you know that it's a string, and you know that will result in an integer. So basically, on a high level, what you can do is you can replace this program that someone has written with that program, and it does the same thing. You can even say, I don't care for late binding in Ruby, and you already, because you are the Ruby implementation, so you can do magic stuff that a programmer can't. So you can already do a lookup for to I before the program is invoked. You can inline that at that point, which means you can actually compile this to native code. But so far this looks just like inlining. This looks exactly like the stuff that Rubinius or JRuby are just doing just in time anyways. So let's look at the more complex example, which JRuby and Rubinius cannot optimize. Let's say someone wrote a method like this in a library. So this 5 times .inject. You know, a method is complex if it's using inject. Okay. Yeah, so you're the partial evaluator, and you start partially evaluating it. What you don't know is what A is. So you have to keep A in there, but everything else you can interfere. So basically, it takes A. So 5 times is just like having an array, 0, 1, 2, 3, 4, 5, 4, not 5. So, and then you start with A and always add that. So if you partially evaluate inject, which you can because you have the implementation of inject, this method looks like this. And then you can also partially evaluate 0 plus 1 plus 2 plus 3 plus 4. So that method just becomes this. And surprisingly, just adding 10 is way faster than doing 5 times inject. And the cool thing about this, you could also do that in any other Ruby implementation by doing special logic, or you could do that in a Ruby implementation by doing special logic for inject. But the cool thing about partial evaluation is that you do not need special logic for inject. It just works. You evaluate the code with placeholders. Once you reach primitives, compile. Primitive is, for instance, integer addition. As I mentioned, it includes the dispatch. And you leave the placeholders completely as they are, including the dispatch, if you cannot infer them. And they have, for implementing the VM, or the interpreter, they have a subset called rpython, which basically does not allow you to have uninferable placeholders. So it can always be compiled to machine code. And compiled Python is fast. This up here is CPython. This up here, down here are the benchmarks. So on average, 5.6 times faster. But how does that whole thing matter for Ruby? Well, there has been a private project for a while. It was called PyPy. Has been released yesterday as Topaz. You should check it out. It has a pluggable GC, transparent object elimination, like getting rid of objects that are just intermediate objects, which really optimizes memory. In theory, which is not yet the case, but in theory, large parts can be written in Ruby later on. So it allows them to do the same thing as maglev did, just copying stuff from Rubinius, which is also really cool. That's something to look into, because the whole language thing I think is important, because if I want to hack on it, I don't want to necessarily go to Java or C just for playing around. Yeah, so Ruby, where are you going? And wherever we take it. Okay, that was a bad pun, but thank you. I don't know, questions? So Topaz is not yet compatible. It's not, I think, except for hacking on it, it's still not even really usable. The standard library is basically non-existent. Threading support is not there yet, and some other stuff is missing, but it's already, the core implementation is already quite far because they've been working on this, quite a few people for quite a while. So it's not something you would use for deploying your app. It's not something you would even use for developing your app, but it's something really cool to keep an eye on. Because maybe that's where Ruby is going. Because so the partial evaluation can optimize a lot of stuff. Imagine you have a Sinatra app that just says get / then renders some ERB, but that ERB does not depend on your database, so it will just always be the same. So partial evaluation can recognize that and can basically only generate the output once, and then whenever a request comes in, reply with that directly, and that all transparently, and once that works well enough, which is really, really cool because that's a way higher level optimization than what other implementations can do. I don't think that will happen anytime soon, because the community is used to taking way harder dictatorship from Rails without having forked it. So I would see that happen first before anything happens to Ruby. And what you also have to see is that people that are involved and say we need to change something are people that really, really care for Ruby as a whole. Yeah, I don't see that happen, like at least not big time that it gets any adoption. Yep. Oh, yeah. So JRuby, I think, so JRuby used to have ahead of time JVM bytecode compilation. I'm not sure what the tooling is there right now. What you in the normals, on the normal circumstances would do is just always ship the source code. But you can also ship a compiled version. GitHub used to do that for a while, just ship the bytecode. I'm not entirely sure what the tooling there is because I never did that. There are definitely tools for just building WAR files out of Rails applications and just deploying them. That definitely works, but I never did that, so I don't know. Nick Seeger is the guy to talk to. He did all the WAR generating tooling. Okay, then thanks again.